Well, good afternoon, everybody, and welcome along to Data Platform Downunder. My name is Warwick Rudd, and I'm your host once again this month. In today's session, which is our third session for March, we've got Christian Cote talking to us about feeding the modern data warehouse. Now, I have mentioned this session is being recorded. You can come back and YouTube channel, Data Platform Downunder, and have a look at all of our previous sessions so far this year as well. I haven't got a whole lot more to introduce because we keep this very informal. If you do have any questions, raise your hand. I will be monitoring the chat window and we'll get this session rolling. So without that, I'll now hand over to Christian and he can continue with this session.
Yep. Good afternoon. I guess it's the afternoon for you. For me, it's the evening. So this is the time zone different, but this is the magic of internet, right? We could not have done those kind of sessions 20 years ago. So let's talk about the modern data warehouse here. So yeah, let's speak. Who am I? I'm a data engineer solution architect. I work at Avanade. Here, I did a lot of on-prem. I have 20 years experience on data warehousing, BI, like someone was mentioning before, universal semantic model. We saw a lot of those kind of semantic model over the past few years, which is normal because they want to answer a specific answer. So this is, I did some on-prem ETL development using DTS, SSIS, Hummingbird, Genio, Informatica Data Stage. I have a lot of data warehousing experience. I wrote several books on data integration, mainly on Data Factory. And I'm a Microsoft MVP, and I'm Montreal Data Platform User Group leader. As I said, I'm French. Maybe people are not aware that in North America, we have a French, I would say, province here, that, and we have something like 7 million, and we speak French. But we kind of are isolated from the rest of the continent. But that's fine. So that's why, as I said before, I might have an accent. I will try to speak slowly. And if it might help, yeah, I got it. Let's go with the subtitles here. All right. So we're going to talk about the modern data warehouse. The pipeline architecture, ELTTL pipeline architecture, the technical challenges, how we query the modern data warehouse, and cloud advantages over on-premises, and we'll do a summary of it. Right, so let's dig. So this is a classic architecture. I would say the most modern architecture we can have when we talk about a data warehouse. We have some sources, Oracle, SQL Server, text files here, goes into the staging, can be persistent, can be transient, which means we keep the history or not. If we use, we can use a data vault here. So with the raw vault, the business vault, for those who had some kind of experience with data vault. Then for that we have the data mart or information mart, and then we have semantic layer here, the cube, or we go directly to the reports. The problem with that, we have a few. If we want to access those things like cloud data sources, you need to open your ETL server to the cloud. It might not be only Azure, because if you use SSIS, you have some Azure component that you can use in your toolbox, both on control and data flow. But it might also be some private cloud, like we were using at some point Workday here, and then to connect to Workday, we needed to open our ETL server, the ports to connect to that private cloud. So it might be a security breach. And also, SSIS was not meant, I would say, if we in the Microsoft Word for the ETL, and most of the ETLs like Informatica is the same, we're not meant to deal with JSON data like REST services here, or NoSQL or unstructured data. They were not meant for that. So this is what we have on premises. It's still possible to deal with it, but it was not meant for that. So these are the challenges that we have with the data warehouse here on-prem. So increasing data volume. When I started 20 years ago in that industry, we have something, we're loading a big 700 megs compressed CD-ROM, right? Receive that monthly. Receiving a CD-ROM monthly compressed data, text file, that we needed to uncompress and load it onto the Oracle server and issues a SQL loader script just to unload that, to load that big files, which was something like 1.5 gigabytes into our Oracle database. So for now, 1.5 gigabytes in 2021, it's nothing, right? It's pretty small. But at the time, it was quite huge. You have to remember that at the time, the servers had something like 2 to 3 gigs of RAM, right? Now I have more than that on my phone. So, and just a fun fact is that once our database was doing 70 gigabytes, which was quite huge. And I was in the pharma industry at the time, it was quite huge. And just to restore the database, it took something like 8 hours to restore the database once we found the right tape backup that was working. So this was in the story here. But so what I mean is that we were receiving data monthly. Data was aggregated on a monthly basis or weekly basis in that file here, and we had some time to load it. We have 5 days to load that data. So it was okay. And at the time that they developed the first data warehouses, most of the people were loading their data monthly or weekly. So but what happened here is people wanted real time. Real time with BI and analytics, I'm not sure if it's relevant because real time is more operational than analytics at some point, which means that if I want to have the latest ticker from the stock market, if I need the latest ticker to make a decision, maybe it's not more analytics but more operational. What I prefer to say is that the near real time. Near real time might be have the data every hours, every 10 minutes, every 15 minutes, and then I can find some, I would say, some new trends in my data by aggregating it to the past, right? Then I can see what's happening here. So the real-time data, the traditional data warehouses were not meant for that, right? We had at the time a streaming site that came with the SQL server that we were able to install. It was a separate installed component. We're able to do some, and it meant a lot of .NET. For people doing data warehousing, .NET, we use it, but not that much. So that much, not that much. So this is what was happening here. So also new type of data sources at some point. You can't imagine how many times someone asked me to load into my warehouse a PDF report. At some point, tools, we didn't have Python at the time. So we didn't have any. We have some available library that we could purchase to work with C#, but it was not meant for that. And also, reading a PDF was not straightforward. It's like reading sometimes a semi-structured text, like a Word document with tables, right? It was not that easy to integrate here. And of course, as mentioned before, cloud-born data, Web 2.0, social media. Like you want to do sentiment analysis, a traditional on-premise data warehouse could not do it for several reasons. The volume, right? Because we have more volume, so we were not able to integrate that much volume on an on-premise data warehouse at some point, unless we had clusters of them, and even that the distribution was not that easy. Usually we install the database server, an instance, and to scale out that instance, we need something else like parallel data warehouse, which is Microsoft Azure SQL data warehouse, not now renamed Synapse. But we had some of these kind of, I would say, databases or special hardware on premises before. Now, we're talking about the data lake, and we're talking about data warehouse. The data lake, the pros of it is that it's easy to load data by many different people. You don't need a specialized ETL tool. Even now, it's easier. You can use Azure Storage Explorer, or you can even upload it using, if you're in Microsoft, you can use the portal .azure.com to upload some data into your data lake, right? And then you can query it using Power BI or anything you want. You can distribute that to many people. It's easy now. The problem is that it might be manual or automated process, but usually the consistency, it's not very consistent. And you don't want it. You don't want your data to be consistent much into a data lake. You want it to be sorted, all right? I'm going to talk about that later. You want it to be organized up to a point, but the consistency, you don't care much about that. Not that you care about the quality much about your data into your data lake. You simply input data there as soon as possible, and you want to do some query on top of it. And it's schema on read. So because of all of this here, right? We're talking about easier to load, consistency, schema on read. Schema on read is a nice feature, but sometimes for the end user, it's harder to query compared to a good old relational model. Now the data warehouse here, this is the easiest way to query the data because it's clean and validated. When I'm talking about data warehouse, I'm mostly talking about the portion that we use to consume the data, which is the data mart here at some point, or the star schemas. But it's to input that data into the warehouse requires a great deal of effort, right? Because you need to have a data model, and it's schema on write, which means that it doesn't allow much errors. If you have a column that is not nullable and you try to put a null inside of that column, it will fail, right? It will not insert. And the detailed historical data is very much limited compared to data lake. Having petabytes of data into a data warehouse is possible using Synapse, managed SQL pool. But for many databases, they have some limits on the amount of data that you can have. Or we can use a combination of both, which is the data lakehouse. So basically, in the late 80s, I would say 90s, and then beginning of 2000, beginning of the century, we're talking about data warehouse here, ETL, data marts. We can have a little layer here with the data vault at some point. And then you have BI, then you have your reports. Then it was not sufficient because of all of the reasons I said before, schema on write, you need to do a data model. Sometimes you would just want to do some, we call it at the time data mining. Now it's called data science at some point. We wanted to find some trends. And to find some trends, sometimes since we cannot integrate everything into our data warehouse, we need to look at the raw data. And the raw data is much bigger than what we integrate because here we make some choices. We filter some data in our data warehouse. That lake, we don't filter anything, right? We put everything into a storage at some point. Then we can do ETL. We could do data marts on top of it, but it was mostly the data lake part was used here. And you can do some real time, which is tough to do with the traditional data warehouse. Now we have the data lake house, which is a combination of both of them, both the combination of the best of both worlds, I would say. So you have your streaming data, you have your batch data that arrive. I'll talk later about that. Then you can do your BI, you can do your analytics on your streaming data. You can do data science, and you can do machine learning. So you have all the richness of the data warehouse and the data lake combined together to do your analysis and to, I would say, to consume your data. So the evolving approach to analytics, are we doing ETL, ELT? Traditionally, we're doing ETL. We're extracting the data using ETL tools, SSIS, informatica data stage, transforming the data and load data into a warehouse or into a data mart here. So this was the traditional way. But now, when all of those new data sources arrive, or the volume gets so big at some point that we had to filter out some data, we didn't want to filter out the data in at all, because we wanted to do some other analysis. So another concept arrived, which is the data lake at some point. And the data lake here, what happened is that we extract the data. We call it ELT, but it's more ELTL at some point. So we extract, we load into a data lake. Then here we scale out the storage and compute. So we have a lot of storage there. We might have multiple storage accounts in Azure, I would say. And then after that, you can use Spark, like with the Databricks. You can use now the Data Factory that is able to bring all of this data together and create a data model for you, the data mart. So, but the data lake house is the combination of both of them, basically. So it's not because you have a data lake that you don't need a data warehouse, right? And it's not because you have a data warehouse that you don't need the data lake at some point, right? Both are playing an important role at some point, because here you deliver something data that answer a lot of questions. Here you can use it to answer specific questions, right? So this is why you might use a data lake here, and you can have multiple questions that might be answered. They are harder. It's harder to query, but you can find answer that you would not load data into the warehouse. I gave you an example before about the PDF that they asked me to load into my data warehouse at some point, or my staging area of my warehouse. At the time, we never did it, because we said, you know what, I need to purchase a library, I need to load it, and where will I put it into my database? Where will I will load it into my database, right? I need to create a bunch of tables, and it's a lot of effort, right? Simply put it into the data lake, use Python to extract the data from your PDF to find the right library in Python. You accept your PDF, you can use pandas after that with the data frame, and then you can consume your data, right? You can aggregate your data as you wish. So for those kind of data, it might be simpler to use the data lake instead of the data warehouse. So the data lake house, basically the concept has been created by Databricks early in 2020. Of course, they want to sell their Delta tables. So I will talk about that a bit later. Basically, you build a data lake first, right? If you don't have anything, let's say you build a data lake first. As needs arise, so you have a user that asks you always the same questions at some point, or the same type of report, you build cleaner table on top of it. And clean tables, once you have a bunch of clean tables, you can integrate them into a data warehouse or data marts. So this is how Databricks envisioned this. And this is basically, when we don't have anything, this is how we start, right? Now we have the capability to say, let's put it into a blob storage account, a data lake, and we're going to, and then as needed, we're going to create the proper structure to build our reports. Do we have any questions so far, Warwick?
No, not at this stage.
Perfect. So I knew I was clear, clear and concise. All right. So the technical challenges that we might face with the modern data warehouse, right? Data lake is not a data dump. Some people, and 5 years ago, I was at a client place, and it was tough because it was an on-prem data lake that they created at the time. It was simply a file server, basically. And the folders were not representative of the data that was inside of it because people could put the data everywhere. You need some kind of governance at some point when you have a data lake. I like Bill Inman, one of the, I would say, operational data store, and it was and Ralph Kimball at some point was at a different school of thought. But anyway, Bill Inman, what he described, the sections of your data lake is a data pound. So you create some section, you organize your data lake into small pounds, and those small pounds after that can be queried more easily or consumed or easier to understand by your data consumers. Here, also stream ingestion, right? Be careful because now we have the capability with the cloud, especially, but on-premises tools are not meant to integrate these stream data easily. I remember when we were doing Stream Insight at some point, the bottleneck was basically the stream engine at some point where you have too much data to integrate. A few years ago, I was at my client place and they told me that they have an issue with streaming data. Instead of, they had the volume of 10,000 rows per hour. All of a sudden, the vendor decided that he was doing an initial load and he sent 60 million rows, which make a big difference. So when they told me the problem, I thought, okay, the problem must be the event hubs, right? The event hub can scale, but up to a point. And so I was sure it was the event hub. So I told them, if you look at the partitioning and everything, the guy said, no, it's not the event hub. The event hub scaled perfectly. The problem is that the tool, what we created with using Databricks after that to consume that data, it was not able to absorb it. So the code we wrote was not efficient enough to absorb 60 million rows in 1 hour because it was meant to integrate only 10,000 rows on the streaming basis, right? So that's why we have some challenges. We have to be careful of the stream of the data. Now, if you use Databricks Auto Loader, you shouldn't have much problem because now tools like that will stage your data into a data lake at some point. So if you have big files, you will be able to replay those big files later if your program were not able to handle them. And also, the file format, the 60 million rows were all CSV, and even have created an Avro file with that, right? So CSV is not compressible, and it's tough to partition using it. So the best format and the standard that we have now in the cloud is Parquet. Parquet, as you can see, would compress the data by column. It's a columnar format. It's a bit like if you do SQL, if you have SQL Server, it's like a cluster column store index on your table. So it's going to compress by column, and it's easy to split. If I want to partition horizontally, it's going to be tough, right? Because I have row 1, 2, 3. If I want to partition horizontally, I can say, you know what? I will put my session IDs into a partition and timestamp and source IP in another partition. So if I query using only my session ID, it's going to be very fast to retrieve my information. So it allows you. So we call it splittable. It allows you to react. I would say better with partitioning. Next slide. Okay, perfect. Also the joins, right? I spoke with Data Vault before about Data Vault before. Data Vault means we, for those who don't know, we take some data like you have the customer, you have the addresses here. So usually we have that into the same file. Now we're going to split everything. Like we're going to take the customer name into one table, and then after that, the customer address into another table, the addresses, and then the phone numbers, the emails into separate tables, and we link them using bridge tables. So we call it link tables. So it means that I describe something like 5 tables. We might have something like 9 tables to query if we want to reconstruct that, right? The reason that we want to break it into separate tables is that you have a lot of flexibility. If your schema changes, sometimes it's easier to say, you know what, my phones go here, my email address go there. So it's easier to deal with than if it was a structure like a traditional data warehouse or data marts. The problem with that is that those data vault thing, and that's the reason why they don't scale. They don't scale a lot. They don't scale well on the cloud. It's because they requires a lot of joins, and joins is the most expensive operation in Spark. So that's why I say Parquet compression is a no-brainer at some point. So we use Parquet as much as possible, and also Parquet will contain the schema inside of it. Usually when we do joins and we require the large volume of data to be partitioned co-located. So on the same, they should be on the same worker. When you have a cluster of machine distributed environment, they should be, you have your executor, you have your driver, you have your workers here. So you try the large volume, you try to put them onto the same worker as much as possible. So when you do a join, they are going to be co-located. So it's easier, it's going to be faster. So to optimize the response time here. And you have something like Z-order clustering, which is kind of data skipping. So it's some kind of indexing that we have with Spark 2 that we can use. But we don't have indexes like we have into a table because basically it's files here. So there are different type of join, right? Shuffle left join, which is the basic one. So it's going to, if your data is co-located, it's going to match on the column that you decide to. It will always map on the column that you decide to. But basically, this one is the most basic one. Broadcast as join. Basically, if you have dimension table, you have fact tables. If you say, I want to broadcast my dimension table, they will be replicated on all your workers. If I go back here, so my dimension dim customer will be here, here, and here, replicated in all the nodes of my cluster. And if I have a fact table here and there, they will be able to access the dimension locally. So it will be much faster. Cartesian join it's self-explicit here, right? We don't join, right? We join every row with the other table. One-to-many join and theta join are really rarely used at some point. So basically, when you join 2 fact tables, right? In one fact table, let's say you have the sales header, you have the sales detail here. This is what they call a one-to-many join. You cannot broadcast those tables because that would be the ideal scenario. You cannot broadcast them because they would not fit into the worker memory. So that's why now you call the one-to-many joins. You have to be careful with those kind of joins because the number of rows joined that can be very high. Theta join is simply you join 2 tables strictly by key. You may need to, but instead of checking of control, you need to provide some hints to get Spark to run well. Theta joins are not used much, I would say. The most joins we use is shuffle and broadcast. One-to-many might happen, but theta join is mostly used with lots of volume in data science projects. So also the modern data, we have different type of data modeling. I told you, forget about the data vault with Spark at some point, because anyway, I speak about Spark. I can speak about Synapse data warehouse. Synapse I would say would react better with the data vault with many joins. But if we talk about Spark SQL, at some point, star schema it's still, even with if you use Power BI, you use star schema. That's the best structure that you can use. It's performant, easy to understand, and sometimes if we have too many dimensions, we can combine them into our model in Power BI. But still, this is the best structure. Or we have flat files here. So I was working at Montreal McGill University 4 years ago, and we had that view that had 444 columns, 454 columns. And me, I said, that's crazy, right? I want to load that in Excel. And okay, Excel, in the pivot table, we can have 16,000 columns. But you don't want to expose 16,000 columns to your clients, right? But people love this view with 454 columns because they were used to it and they have everything together, right? But I would say, to me, it's the bare limit. Sometimes what people do when we don't have a large star schema, let's say I have only 4 dimensions like here, I will do the join here between the fact tables and the dimension, bring big, and with the star schema is easy. I don't have too many. So and beginning a large flat table of 200 columns, and then I can expose it to the client, a bit like a cube would do at some point. It's to simplify the user's experience. What I want to say here is that those type of star schema in flat are the most performant that you can have in Spark or in the cloud here. So this is what I want to say. Too many joint is not good. This is what I want to expose here. So the ETL and ELT pipeline architecture here. When I would say when Hadoop arrived in 2009, 2010, we talking about the Lambda R architecture here. So they define it like saying, you know what, this is my Lambda architecture, and if I use this here, right? So I have my streaming data here, and I will go up to my data consumption, and we'll do some queries here to aggregate it and put into my my systems, right? Might be a database, might be a data lake, but mostly it was a database at some point, and the queries here were with Hadoop, right? So I cannot rewrite it properly. And then after that, I have my batch classical layer. The problem with this approach is that sometimes, pick another color here, they wanted to use the streaming data, right? And bring it here, oh boy, bring it here, right? Into the batch layer at some point. And sometimes they say, you know what, I have my streaming layer here, and I would like the streaming data to integrate it directly here. And sometimes they say, oh, that's the opposite. Let me take the blue one. I want to take the batch data and integrate it with my queries here using the streaming layer. So we have all kind of point-to-point integrations, and it was not working. It was not working. It was tough to design those kinds of pipeline. It was possible, but you needed a very good model and a very good governance at some point here. So what Databricks did a few years ago is to say, you know what, let's do Databricks Delta, the Delta pipeline, basically. So you have all of your data here, right? And then after that, you have your raw table. They call it sometimes the bronze layer. You have your query table, which are the silver, and then you have the gold, which are your fact table, basically. So this is your staging here. This is your dimension. This is your fact here at some point. And then you're able to say, you know what, I can query all of that here, and I will integrate that into my system. The beauty of this is that on the same pipeline, I can have my streaming and my batch data. And Databricks last year, I think it was in July, they released the auto loader that you can say, you know what, I want to take my batch data every hour, but still bring me my streaming data. Streaming data and batch data, the problem we have is that we need at some point the data might not be complete. I might have a transaction, but I don't have the dimension that goes with it, right? I might have the customer ID, but the customer is not there yet. The customer is going to arrive in half an hour, right, to complete my transaction. So this is the challenge. With Databricks, that helps because everything is on the same pipeline. Because if I go back to this one here, if I'm talking about this is my transaction here, right? And this is my customer data. So that's why sometimes we needed to combine those two because we want to, you know what, I want to get the customer if he's there on the batch layer and put it into my source system, my system here, my warehouse. So this model is it's easier to work with, and I'm going to talk later about the Databricks Delta. So you are going to see that it has a lot of advantages. So yeah, this is the Databricks Delta. It's open source since spring of 2019. It allows a SID transaction on Spark, which means that you have the serializable isolation level. Make sure that you never see inconsistent data. You have scalable metadata handling, all of these advantages, stream and batch unification. That's what I was telling you. Schema enforcement, yeah, because you're using Parquet file, you have the schema here, and you have the time travel. For people who used temporal table in SQL Server, it's the same concept, but it's easier to go back in the past because you can compare one version to another using or version ID or timestamp. But I mean the tools like Synapse or Data Factory are can integrate those type of delta table easily here. And then after that, when we go there, Microsoft is pushing the common data model, which they call now Dataverse at some point. So the common data model here, what it is basically, and me, I like this concept because how many times did I did I would say a customer dimension, right? If I did a customer dimension in North America, chances are that you did something very similar in Australia. It's not because we are from different countries or different organizations that the customer would be much different, right? We have a core, like here, we have a core here at some point, and this is what Microsoft is pushing. Microsoft, Adobe, and SAP are have a joint, I would say, project on that. So the way it works here is that you do your data integration from different, I'm going to show you a demo after that, how we can do it using Power BI. But you do your data integration using the Power Apps stuff here, or you can have other application. Let's say that Power BI would be here. I will be able to integrate that into my, you see the Power BI data flows here. So I will use the Power BI data flows to import my data into my data lake, but I will create entities. So it's not a file that I put somewhere. I create entities after that, and those those entities, those tables can be industrialized or operationalized or productionized by data engineers after that, and they can create the proper structure into your data lake or your data warehouse. So the way it works for Power BI, the structure of overview, basically, you have the common data model they started with all the entities that you had in Dynamic 365. So this is an example here. So you have your account, you have your entities here. So, and then after that, you have your file system. So the file related to those entities will be stored into subfolders. So, and that represent your CDM folders here. In more detail, for those who did some analysis services, model.json, this is a cube at some point here. It's just, I mean, this is how the tabular models, when you see model, it's like a cube here at some point. And then you have your entities, which are the CSV files. And I think that, yeah, here. So the modern data warehouse life cycle, I would say, forget about the Power Apps. Let's say we start with Power BI, right? This is our ecosystem at some point here. We might have machine learning, we might have SQL data warehouse. But what we're doing, basically, we want to ingest data because a few years ago, we were, the way to create our models was to use a data architect, hire a data architect or find a data architect in the enterprise that knew the business, or with a bunch of business analysts, and we had this analysis phase here. We needed to analyze and we needed to create a model. Then you had the ETL developer that were loading that model using their ETL tool of choice. And after that, you were seeing, you were showing that to the client 3 months after, and the client told you, this is not what I wanted, right? Or this is what I wanted, but you need to make a bunch of modification. So the way that it works now, you ingest your data using Power BI data flows. You can create reports directly on that data flow here. And then after that, once it's ready, Data Factory can now read and write to common data model folders, or you can use Databricks here. And then after that, you can do some machine learning, and then you can load it into your data warehouse. So the flow basically is that use your data first, because one thing is when you speak to your clients, usually they don't know what they want, right? You show them their data, and then now they tell you what they want, how they use it. So this is how we should work. Remember at the time, beginning of the century, I was in a company that, the same company that we were loading data monthly, as I said at the beginning. I'm sorry. And then that company, we spent 3 months, right? It was a waterfall approach. 3 months to do analysis. Then we spent 3 months developing for that. And so 6 months after, we get back to them, and half of the report were not what they wanted. And we needed to do a lot of modification into our data model and our ETL. So integrating data is 70% of your data warehouse project when it's not 80% of it. So now we have better tools for that. If you can understand the requirement for your clients in advance, that helps. And if you can skip sometime up to a point, this part here, that might be faster. I'm not in favor of it, but sometimes if it's an ad hoc project, you can simply say, you know what, I will do it in Power BI. And if you need to refresh your model, I have a client that every 6 months, they put an Excel into a share folder, and then they refresh their Power BI. This is all what they need, right? But before that, it would have been tough, right? To answer, we need to put that data into a database. The format might change, the structure might change. If the structure change every 6 months, the client will make his modification in Power BI, and he manages his report. All right, so let's go for a demo. Do we have any questions so far?
We do. So Craig, if you'd like to ask your question.
Yep.
Yeah, Christian, I'm just going to take you back a few slides to
Sure.
where you were talking about the data Delta Lake,
yeah.
Jobs that were batch and streaming.
Yep.
Now, I'm assuming in that scenario, it's quite possible, and in fact, I've already seen it, where you got the same data arriving in the streaming hubs as you do in the batch hubs. So how does Delta Lake have built-in capabilities to handle that duplication for you, or is that something you have to code?
You have to code. You
Okay.
have to code. You are on you're on your own on that one. What that I think will help you is that if you override that data for some reason, you can see the previous version, but that's about it.
Okay.
So you never lose anything.
So you got to be careful that you don't end up duplicating the same actual transaction.
Yeah.
Just because one's the one is the copy that's arriving in a batch fashion, and the other one's the one arriving in the streaming fashion.
Yeah, but most likely those scenarios, what will happen is that the streaming version will have maybe the keys and a few attributes, and the batch version will have the complete or corrected data, right?
Yeah.
So this is where you need to be careful when you code, because and sometimes it's most or the opposite, right? The batch data might be erroneous at some point. It might be bad, right? So this is where you have to be careful. The only tool, as I said, is that Databricks gives you a possibility to travel back in time. Back in time might not be yesterday, or the last one it might be a few seconds ago, and to see what you had before. But you on your own, you need to code it by yourself.
Mm.
And even streaming stuff like stream analytics with Microsoft, it's you again on your own on that one. But you have more. I would say that's why stream analytics like Databricks, Delta R architecture are nice tools, right? At some point, but you need to code for it. Stream analytics, usually people will lend data into a data lake, and they will use Data Factory after that or Databricks to manage what arrived there.
Thank you.
No problem. Let's go to the demo. Yep. No. Discard. Perfect. Okay, let's go here. So let's go back. This is my data flow. This is my data flow, but let's step a few. Let's go a few steps back. Yeah, that's fine. Yeah, I need to cut it. So basically, what I did here, I create an entity, Microsoft stock 1 year value. I take it from Yahoo. So Yahoo here. So at first, I had a file. So the file that I had was something like, do I have something like that here? My clipboard history. No. Yeah, here. I had, let me put it into another browser page here. This is query.finance.yahoo.com here. And Microsoft period 1, so you have 2 periods, right? Period 1, and it's a unique Unix timestamp here. Unique timestamp, for those who don't know, it's they count the number of seconds since 1970, something like that. So this is what they are using here. So from 1986 to 2019 here, and so interval is 1 day. Basically. So, and yeah, and we have other parameters. If I do it, I'm going to download the file. I did it a few times, and that files look like, when it's going to open, look like that here. What I did with Power BI, I use a web connector. Let me go back to Power BI. Yeah, that's the Power BI. Thank you. So what I did instead, I connected to it. And so I created the data flow. So the way I did it, I went to my workspace here, and I say new data flow here, right? New data flow. Then it asks me, what do you want to do? Where do you want to get your data? I choose define new entities. And from there, he asked me, how do you want to connect? Me, I said, I want to connect here, well, using web API. This is what I use, and then I was able to pass my my query, to enter my query. So let me remove the zoom for now. So I won't recreate it now. Yeah, that's fine, cancel. Here, let's go here, and let's Microsoft 1 year value, and I bring also Oracle stock 1 year value. So I define my ITT. This is how I called it. And then here we'll see all of the steps I did, right? Let's say I'm the analyst here. I connect to, I don't want to bring all of the stocks from 1986 to 2020. I just want to bring 1 year of data. So 2019 to here, and we go to 2020 at the end of 2020. So it's not sorted. So my source here is, you can see this is the query finance stuff here, right? The same query I use, delimited by comma, and yeah, and then after that, all of those columns equal 7. I have 7's column, and it's not single quoted or double quoted. Then after that, we promote the headers. Yes, that's fine. And then after that, we change. So I did all kind of modifications here. The date was not recognized mostly by the Databricks or the data factory, so I converted to a string. Here, I had to convert it to a string, but those adjustments were done. So now let's imagine I created some reports for my client. My client say, yeah, this is what I want. I want this transformation or that transformation. Now this is the part that my client has it, and then I can expand the period. Let's say 2 years, and my client have something, right? It's not productionized, it's not industrialized, but it's based on 2 data for Microsoft 1 year, Oracle 1 year. Combining them together is another exercise that we're going to need some IT specialists, I would say, data engineer. So now we go to Synapse. I could have used Data Factory, but because Data Factory and Synapse data flow, Synapse pipelines is basically the same thing. And then I use my copy activity. My copy activity, I use a data set for Microsoft stocks here. If I open it here, now my query will be from 2006 here to 2019. Here, this is what I have. So I can test my connection. Everything is fine, and I don't have to write code much so far. Just my query. Same thing for Oracle. And then after that, I can go to my data flow. For those who don't know, data flow, I love them very much because they use Spark compute here, and with Data Factory they use Databricks virtual machines. So they convert your code, your transformation that you have here, into Scala queries. So this is, but I prefer to work with that because let's see, you see here, I said I will use my Oracle stock from my common data model. So because my data flow here put it into my lake, and then I was able to retrieve it with my common data model here. And this is from my historical stock. This is what I transferred directly from the copy activity. So I take 1 year and the rest of the years here. And then after that, I can add some columns. I will add the company name, which is Oracle, and in that case, it's going to be historical Microsoft. Yeah, company name. Yeah, here, Microsoft. Here at some point, I can do I can shape my data here. So I will say, you know what? This is that date is called a date because now I converted my date to a real date, not a string. Because Data Factory was able to read that string and convert it. Then after that, I union both streams here. And what I like about Data Factory is that anywhere I can preview my data here. So it takes a bit of time because I need to wake up the cluster here. But anywhere I can do it, I can preview the data. We'll see what will be inserted, updated, deleted, upsorted, and if I have any lookups. And yeah, oops, oh wow, nice. It was working a few minutes ago. Yeah, okay, that's fine. Must be because I need to restart my cluster here. Bear with me, it work. It's only because now we have some issue with my cluster. I need to restart it. This is a problem we have with Synapse. Even though I still I want it to last for to live 4 hours. After 1 hour, simply I need to restart it. So, but I ran it before, so I will show you what happened. What's nice with those kind of flows here, and what I like about it, let's say I want to add a lookup. Let's pretend I have a dimension. I want to add a lookup. What I want to show you here is that I can match on multiple rows, any rows, or if I say first row, it's going to ask me, because I don't have any string, let's see, that guy here. First, what column do you want to sort, right? You want to sort ascending, or you want to sort descending. Sometimes we want to have the latest slice in our dimension. We say sort descending on that specific column. In our case, I will use any rows. And what I like is the optimize here. If I go here, I will say broadcast. Remember when I told you about the broadcast as join? The way to do it with Databricks, it's not easy because you need to have a hint broadcast into your query. With Data Factory or Synapse Dataflow, what I like is this here. You can say fixed, which means that it's going to fit in memory of my workers. Now, I want to, what do I want to broadcast? Both sources here, I can do it too. I have to make sure that it's going to fit in my cluster memory. But so it's possible. So where I want to go is that I can go here and I can go back. I did the same pipeline that I just showed you here using Spark. So you see, now I need to create my my data frames here, our record here. And then after that, I can add more data from 1986. I need to use pandas at some point for those who know pandas, because I need to use pandas because I'm querying a URL. For those who know pandas, you know that it's not distributed, so it's only working on the driver. So if I have a lot of data, I'm going to make my driver blow up. So this is a limitation that we have here. And then look at all the code I'm doing to finally unionize my two data frame here, add the column names here. Then after that, I can add the date columns here, row hash value if I want to, sequence column, and at the end of the day, I'm going to post it to burst it into my data model. Basically, what I show you is what I have into my if it come back to my pipeline here. So if I need to do, like I showed you before, I want to do broadcast join and stuff like this, to me, it's simpler to do it here because here it's no code. I simply need to link my stuff here. It's going to send an optimized Scala query at the end of the day to my Spark cluster. And for those who like Spark, I'm going to show you something. If I go back to my pipeline that I ran before, let's go to the output. You can see that it ran before, and this is the output of it. Now, I click on that, I can see the partition that was used. Here, now I use 2 partitions at some point, but 1 would have been sufficient, right? I don't have a lot of data. I'll have the skewness here, it's not available, but the kurtosis is mean this one is larger, this partition is larger than this one here. You don't want to have kurtosis like that. You want to have it something like 2 or 3. But right now I have 2, so it's 0.5. So all of these, I don't have it with Spark when I do pure Spark. So I see the partition, I see when you unionize here, it's worse here because I'm using 253 rows and I'm using the rest of that partition. So my partitioning is not optimized. I can fix it easily with Data Factory. I can just click on Edit Transformation. I go here, and then I can optimize and set partitioning. Round robin, because I want to distribute it equally to all my partition. How many partition do I want? Maybe 1 is enough, right? So yeah, it must be at least 2 partition, but I can say no. Yeah, I know why. Because I can say just single partition, right? So it's going to use the round robin. It doesn't have any choices. I have only one partition here. So if I go back, not here, I go back to my, where's my data flow? Yeah, here. So I'm in my data flow. I go back to my pipeline that ran here. So I was showing you that in here, I have all of the controls I want. And at the end of the day, I see all the row counts too. How do we use some row counts with Databricks or Spark, right? You need to, you're on your own. Data Factory give it to you for free. So instead of focusing on the code, what I want to tell you here, you focus on the job you have to do, the integration, the data you have to do. So this is what I like about Azure Data Factory. They did a lot of good stuff here. And if we use Synapse, we can go to here, Spark, yeah, the one that fell before, but that's okay. Spark application here. Yeah, and then I can see here all of the stages. So I can bring the Spark UI. For those who know Spark UI, this is how I can optimize my work here. So I can see the executors, at some point the driver, and I use only one executor, the memory I had at some point, the disk use. So I have everything here. And yeah, I can see the graph, I can play back, which is, it will not tell me much because it failed, but it tells you what happened here. And you can have the SQL at some point, and this is where at some point you will find that you see Scala. It's using Scala at some point here. And Scala, for those who don't know, in Spark, this was before that the Spark 2.0. Scala was the most efficient way to code because it was not using the data frame, and Spark is written in Scala. Scala, which is a kind of it's Java, I would say, but it's more it encompasses every library you have in Java, and it does a lot more because you can use it with Spark. So this is what I wanted to show you on that part. Data integration. Hopefully, you can use the Data Factory here, and you can use your data flow here. And what I wanted to show, I took from my 1 year data, I was able to load it into PowerBI data flow, put it into my common data model, and quickly I will go back to my pipeline here. And here I said, read that from my common data model. Here, and from that common data model, I said, okay, you take that to my root location Power BI, Oracle stock 1 year value here. And so it's the same data flow that I created, and I named this, and I use the entity Oracle stock 1 year value. Same for Microsoft 1 year value. I did the same thing here. So from there, then after that, what I said here I put into and data lake store, but I would have said, you know what? Let's do everything. Now I have a permission issues here. This is why it failed. Let's put everything and put it back into a common data model. Then it can be, and then Power BI can read from the common data model, and everything is at the same place. But what Synapse changed, and I'm going to talk about the consumption right after, is Synapse now we have built-in serverless pool here, SQL pool here, and they can read from a disk using external table using Polybase. So if I go to my scripts here, I will show you that I created here an external, I created a scope credential, I created a format, scope credential, and then I said, this is where my data is. Then after that, I created a view based on that. And if I run this select here, does it run? Perfect. It's going to run. Yeah, I cancel it. It's going to run. It's going to show me all the data I have here, which is my common data model here. I can read from here. And then after that, from Power BI, I can create a Power BI dashboard based on this. I'm going to show you that later. But now, just go back to my demo. I know that I spend more time, but we almost completed here. We almost finished here. So data integration. Now, how are we querying the modern data warehouse, right? Yeah, we can use all kinds of tools that can connect to Data Lake or to your Synapse Analytics, or you can use Databricks. But if you use Databricks here or Synapse Analytics, you can use the notebooks, right? In the notebooks, I didn't show you, but you can create graphs, you can consume it. But notebooks are more meant for data scientists to share the experiments with data engineers, right? You will not use notebooks to your clients, right? Because you don't want them, they should not be there, right? And this unless can design proof of concept using notebooks here, or you can use with Power BI Premium the XML endpoint. XML endpoint, okay, XML endpoint, we use that since 2005 to connect to analysis services cubes. So this is the same protocol we're using. And you can use it with SQL Server Management Studio. You can use it with SQL Server Profiler here, DAX Studio, Tableau. You can use it with Excel, of course, and SSDT SQL Server data tools here. Yep, and this is the demo I wanted to show you. So when you have the Power BI here, let's go back here, Premium. Go back to my workspace here. Let me make it my workspace. Yeah, here now I want to go to the workspaces. Yep. I want to go to the home page, sorry. And my workspace, perfect. Here my settings. No. What I want to go, I'm sorry, I just want to go to my workspace and be able to see what's inside of it. Here and workspace settings, perfect. So if I make it a bit bigger, what will happen here is that I can add the name of my workspace, I can add people there, but when I have Premium, now I created Premium using Power BI Embedded, but if I had the real Premium, it will be the same thing here. And then I can have the workspace connection. If I copy that workspace connection, then after that, I can go to Excel. And Excel I did before, so I was able to go to data here and get data from analysis services. I paste the name of that here, and this is quite clumsy how it's done. Paste the name here, don't put anything here, then it's going to authenticate. The first time it's going to authenticate to using multi-factor authentication to Office 365. And then after that, you can say I can bring the my model here. So if I have Power BI Synapse, yeah, because it's not compatible, I'm using direct query, but I can bring a model here, which is a cube. And Control 4, and then you see this is my cube. I have my measures that I defined there. Yeah, of course, because I time out here. So, but I can query my cube using Excel. I can go into DAX Studio, and then I can say, give me the stocks for 2010 at some point, and yeah, I lose all my my connection connects here. See, it was nice when it was working. Okay, it's connecting. I'm connected. Record 10 years. That's what I have here, and you can see it. Refresh the metadata. Anyway, I'm pretty sure that you believe me that I was able to query it using DAX Studio here. I have some, so I would need to reconnect that query for sure. So this is how you connect. You connect using the XML endpoint, or the last thing I want to show you, you can connect using Synapse. If I connect to Synapse, what will happen is I'm going to use direct query to the view I created IT stock values before that I have a lot of rows there. And then I can create my measures, and then I can create dashboards like that here that can run in the once I need Power BI Desktop to create them. Then after that, I can go to my workspace and I want to see the content of that workspace. And I will see Power BI Synapse, and we should see the same, yeah, the same dashboard that I created here. Same visualizations. Yep. And then I can, of course, I can do anything I want with those values here. I can switch them. I can do a lot of things. Interact like. So, but now I'm using the serverless pool of Synapse here. So I'm connected to my storage account that I created with Data Factory. So let me go back to the presentation. Yeah, that's fine. And go here. So the challenges we have, because sometimes we want to use the cloud, maybe not nowadays, but security. Security, I would say it's a major concern for both on-premises and cloud. Security, I would say I trust the cloud much more than I would trust my company on-premises network, because Microsoft invests millions of dollars I would say every month. They have to make sure that everything is reliable. Reality and uptime, yeah, it's easy to scale up something, to scale up a cluster, right? And to scale up the uptime, I would say. Cloud they spend millions here. 100% of time is impossible, but yeah, the cloud can guarantee 99.9x uptime of the service, and the more 9 you have, the more costly it's going to be. And development environment, for those who use SSDT, for me, it crashes twice per day at some point, so I prefer to develop in web-based tools using Data Factory or even Spark. It's easier. So, and I can develop on I can connect my phone to a monitor, and using a keyboard and mouse, I can develop using my phone. I don't need a big PC for that. Right. So to sum up, cloud data integration allows us to ingest more data sources because we have more modern services there. Power BI, Factory, Synapse, the Databricks are the main tool used in the modern data warehouse in Azure. I specify in Azure here because if you're using Amazon, it's something else. You might use Power BI, but then the Databricks, but the Data Factory and Synapse will not be there for sure. Modern data lakehouse or warehouse is where this tool is leading slowly but surely. They bring everything from their warehouse to the cloud? I think we never do a pure conversion. Usually we'll bring what's relevant to the cloud, and we'll add from there. Yeah, do not lift and shift. That's what I was saying. Lift and shift all of your stack to the cloud as they are on premise, because it's not worth. You have your server, you pay for them, they are working well. So you will do more than lift and shift. All right. Are there any questions?
We do have. So Fernando,
yep.
Would you like to unmute yourself and you can ask Christian your question?
I see. Can I see the questions here?
Just put their hands up. So
yeah.
Fernando is first.
Fernando, yeah. Go ahead. I think you're on mute if you want to speak with me.
We can move to Rutika.
Yep.
Hi, Christian. I just had a simple question. Which would be the best tool to ingest data into the data lake when you have like internal and external sources?
Data Factory, I would say.
Data Factory? Okay.
Yeah, Data Factory, and it's because like internal sources, you can use a self-hosted integration runtime that you can install on your network, and you can. This is the best tool for that.
Yeah, so I mean, we have like CRMs like iTrack and D365.
Yeah.
So Data Factory would be a good option.
Yeah. Data Factory would be a good option. And what I like about Data Factory is that you don't need to know. You can scan your tables and you bring what you need, and then you can use the copy activity, which is serverless. Because I show you serverless and compute. When you use the mapping data flow, you're paying for the compute and you're paying for VMs, right? Like 8 machines. If you use the serverless, like copy activity, you're billed at the millisecond, and it's not very expensive. Canadian dollar, 81 Canadian dollars for 1 hour if we use all of the resources.
Okay.
So it's not very
And
expensive.
also we have like, many Power BI reports directly connected to the CRM. So, I mean, but the performance is really slow. Like it takes hours to refresh the data. So, I mean, we are planning to move it to the data lake. So would you recommend doing it the way you showed in the demo today? Like connecting it to data flow and then doing the transformations in Synapse? And
I would say, okay, yeah, I want to ask you a question about that. Do you import the data in Power BI? Is it Power BI service, Power BI Premium?
It's premium.
Premium. So you import your data into your model, right?
Yes.
So, and when you import your data, so you connect Power BI directly to your CRM?
Yes.
Okay. And how many tables do you bring? More or less.
I think the more than 10, more than 10.
Then it's nothing. I'm surprised that the performance is slow, but maybe you have a lot of data there. But if Power BI has issue to bring the data, I would say bring it. Okay, because it depends. Power BI, do you load your data incrementally?
Yes, it's only 1 hour. I mean, 1 year's data, and it takes like more than 1.5 hours to refresh.
Because if you stage it to a data lake at some point or common data model using Synapse, it's going to take the same amount of time to query your data. But one thing you can do with the Data Factory, you might try to run it with many copy activities in parallel, right? So 10 copy activities in parallel. That might be faster, but I suspect that the bottleneck is your server, CRM.
Okay.
CRM.
Okay. Yeah, that's it. Thank you very much.
Thank you. So Fernando, are you back? Yes, if there is anything, you can shoot me an email, and I will send you that presentation, Warwick. It's in PDF. We'll send out to you, so you'll be able to share it if you want.
No problems.
All right, guys.
Well,
I had the one last slide that said thank you, and hope you enjoy.
If there are no other questions, then thank you, Christian, for giving up your time and presenting at the Data Platform Downunder. Thank you to everybody for coming along. Looks like we've got somebody typing, but that's okay. As mentioned at the start of this session is being recorded and will be put up onto the YouTube channel. That should go up later this week. Feel free, if you're not already subscribed to that, to subscribe to that YouTube channel and continue your learning.
All right.
Thank you,
guys.
everybody.
It was nice. Yeah, it was nice to speak to you tonight. Thank you very much.
Thanks, everybody.
Thanks. Bye-bye.
Bye.